Chapter 11, Section 6, in the 7th grade note-taking guide, is entitled Probability of Independent and Dependent Events. Here we're going to learn how to find the probability of different types of chance activities that are successive, meaning two events put together right after each other. But how I find those probabilities depends on what type of events they are. Not so much how I find the probabilities, but the actual numbers that are going to be used in the calculation. So the first thing they describe are independent and dependent events, which is great because that's the section header here. Independent events are events for which the outcome of one event does not affect the probability of the other. Meanwhile, dependent events are events for which the outcome of the first affects the outcome of the second. So what they're saying for independent events here is that these are two events that don't have anything to do with each other in one way or another. They could be totally unrelated events. Like if I was talking about flipping a coin and rolling a die, those two things don't have anything to do with each other. So that would make them independent events because they're just totally unrelated. Now, they could be related though and still be independent events. Let's say I was pulling bingo balls out and I pull out V6. Okay? And then what I decide to do, even though it makes no sense, but it's still a good example, is I put B6 back in the hopper with all the balls. And I say, okay, I'm going to draw again. All right? What type of events do I have there? Well, I have independent events there. And the reason I have independent events there is because the first time around, I've got all 75 balls in the hopper, everything B1 to 075. Because I put B6 back, on the second pull, I still have everything in the hopper from B1 to 075. Because everything is still there the second time that was there the first time, I haven't changed the possibility of me pulling B6. And because that probability doesn't change, that probability doesn't change, that makes them independent events. But let's say instead that I take B6 out and then I decide I'm not going to put it in the hopper, I'm going to put it to the side. Well, that means the first go-around I've got these 75 bingo balls in there, B1 to 075. But when I go to pull the second time, there's not 75 bingo balls in there. There's only 74 bingo balls to choose from. That's going to describe dependent events because now my probability has changed. How do I know the probability has changed? Well, remember, when I write probabilities, it's the number of favorable outcomes compared to the total number of outcomes. Well, that means the total number of outcomes has got to change because it's going from 75 to 74. So they can't possibly be the same fraction with a different denominator. And because of that, that makes them dependent events. That's the difference between independent and dependent events. So, let's go ahead and take a look at the examples here talking about independent and dependent events. Number 1 says we're supposed to determine whether we're talking about independent or dependent events. Kathy draws a 4 from a set of cards numbered 1 through 10 and rolls a 2 on a number cube. So the question is, does me picking a card and rolling a die have anything to do with each other? Well, no, those don't have anything to do with each other. What happens when I roll the die doesn't impact what I'm going to get when I pull the card. And because they don't impact each other, they don't affect each other, that means they are independent. So, now let's talk about finding the probability of some independent events chained together. I'm going to find the probability of choosing a green marble at random from a bag containing 5 green and 10 white marbles, then flipping a coin and getting tails. Well, because picking the marble and flipping a coin don't have anything to do with each other, they are, again, independent events, just like number 1. All right, so to find the combined probabilities, I'm going to multiply together both probabilities. That means I have to find both probabilities first before I can go and multiply. So the probability of me picking the green marble. Well, you see on the screen it says 1 out of 3, but it's not directly 1 out of 3. If you look at the question there, it says that there are 5 green marbles, and if we add it up, do a little simple arithmetic there, there's 15 total marbles. So it's actually a 5 out of 15 chance of me picking the green marble. What they've done, of course, though, as you've already figured, is they've reduced that fraction. Because 5 over 15 is a reducible fraction, 5 over 15 reduces to 1/3. So they've said the probability of getting a green marble is 1/3. Then we're going to find the probability of flipping tails on that coin. Well, obviously there's two options on the coin, head or tails, and one of them is tails. So that's why they came up with the 1 out of 2 that you see on the screen. So now to find the combined probabilities, I multiply those fractions together. Remember, when we multiply across the top and the bottom, and those results make up my solution. 1 times 1 in the numerators makes 1, 3 times 2 in the denominators makes 6. 1 out of 6 is the probability of choosing a green marble and a coin landing on tails. Meaning, if we wanted to talk about experimental probability and theoretical probability, if I go and try this 6 times, 1 out of those 6 times, I should be able to pull green and land on tails. Will that be the actual number when I go try it experimentally? Who knows? But theoretically, it should happen 1 out of 6 times, or 1 out of every 6 times. All right, so as we look at number 3, it says a reading list contains 5 historical books and 3 science fiction books. What is the probability that Juan will randomly choose a historical book for his first report and a science fiction book for the second? So, probability of me pulling a historical book. Well, if we look at the question, it says there are 5 historical books, and there's, of course, a simple bit of arithmetic, 8 total books. So there's a 5 out of 8 chance of me picking a historical book. Then it says, after I pull a historical book, they want me on the second pull to pick a science fiction book. And here's where the situation can change a little bit. Because we've already read that first book, I'm not going to put it back on my shelf of books to read again. I'm going to take it and put it off to the side. So now there's only 7 books left on the shelf. Well, because I've changed the total number of possibilities here, because now there was only 7 books, whereas a minute ago there was 8, that makes this dependent. The earlier questions were independent. Now all of a sudden it's dependent. So I'm going to do that there. I'm going to knock that down to 7 for the total. All right, how many books do I have? I have 3 science fiction books. So that's a 3 out of 7 chance of me picking the science fiction book. To find the combined probabilities, I still multiply though. I'm going to take my 5 out of 8 and multiply it by 3 out of 7. 5 times 3 in the numerators gives me 15. 8 times 7 in the denominator gives me 56. 15 over 56 is the probability of me picking a historical and then a science fiction book. So as we look at the concluding examples here in the Check It Out section, it's asking me to decide whether the set of events are dependent or independent in number 1. And it says Annabelle chooses a blue marble from a set of 3, each of different colors, and then Louise chooses a second marble from the remaining 2 marbles. So the operative phrase here is that she's picking from the remaining 2 marbles. If she's only picking from the remaining marbles, that means the situation had to change. Annabelle's picked from 3, but then when Louise gets picked, Annabelle's choice is gone, so there's only 2 left. The total number of possibilities has changed. If the total number of possibilities has changed, all of a sudden this has to be dependent. Looking at the last one there, number 2, find the probability of choosing a red marble at random from a bag containing 5 red and 5 white marbles, then flipping a coin and getting heads. So, I'm going to combine here to find my probabilities. The flipping a coin and getting heads, you all know the answer to right away. Probability of me flipping a coin and getting heads is, of course, 1 out of 2. You all knew I was about to say that. But as far as the marbles go, we'll have to think about that for just a second. Possibility or probability of me finding a red marble. Well, there's 5 red marbles in the bag, and if we do a simple little bit of arithmetic, there's 10 total marbles in the bag. 5 red and 5 white makes 10 total marbles. So there's a 5 out of 10 chance of me picking the red marble, or we can reduce that down right now and just say there's a 1 out of 2 chance of me picking a red marble. To find the combined probabilities, again, I multiply. So I'm going to do 1 out of 2 times 1 out of 2. Well, 1 times 1 in the numerators makes 1. 2 times 2 in the denominators makes 4. So there's a 1 out of 4 chance of me picking a red marble and then flipping heads on a coin.